So we're looking at section 2.3 homework solutions. This is on page 171 in the review exercises in the back. For number 43, we start with needing to do long division of polynomials. Instead of doing long division, though, we've done synthetic division in class, so we'll keep that up. I have 3x minus 2 in my denominator as a solution that is 2/3. So that is what I put in for synthetic division. And then I have 24, negative 1, and 8. So bring down the 24. 2/3 of 24 is going to be 16. If I take 16 minus 1, that gives me 15. 2/3 of 15 is 10. I got 2 left over, so my answer, this is my remainder, is going to be 24x plus 15 plus 2 over 3x minus 2, my original denominator. Now let's look at number 45. This one, since I have an x squared minus 1, I'm not going to be able to use synthetic division nicely, so I'm going to write it out in this form. So I'm going to first multiply by x squared. I get x to the 4th, and then minus x squared. I bring that down, change the signs. Negative 2x squared plus 2 comes down. I'm going to multiply by negative 2. Get negative 2x squared, that'd be plus 2. Change the signs, and I'm left with 0, so my solution is x squared minus 2. Let's go to number 47. I'm going to do division again. I'm going to have x squared, and I want that to be 5x cubed. So I'm going to multiply that by 5x. So I got 5x to the 3rd minus 15x squared plus 5x. I'm going to change the signs. So I'm left with here is a 2x squared minus 6x plus 2. I'm going to multiply that by 2. Get 2x squared minus 6x plus 2. And by changing the signs, I'm left with 0, so my solution is 5x plus 2. Number 53, I'm looking at synthetic division. So I'm looking, I have x minus 2/3, so 2/3 is my solution. 2/3 of 6 is 4. That adds to be 0. 2/3 of 0 is 0. Bring down the negative 27. 2/3 of negative 27 is negative 18. Add those, that is 0. And 2/3 of 0 is 0. So there's my remainder. So I got to be careful with this. This is my constant. This is my x squared, and x cubed. So my solution is 6x cubed minus 27x. For number 55, I'm going to use synthetic division again. I bring down the 3. 4 times 3 is 12. I have the sum of that is 2. 4 times 2 is 8. Add those, I get 20. 4 times 20 is 80. That leaves me with, looks like 58. That's my remainder. I have constant, x value, x squared. So that's 3x squared plus 2x plus 20 plus 58 over x minus 4. For number 57, I'm going to need to plug in the solutions they gave me, or the x values they gave me, and find out what I get. This is the idea of the remainder theorem, and this is where we could check to see if this is actually a solution. If I plug this in and it comes out to be 0, that means the function value is 0 at that point, meaning it would be a solution that I could use. If it comes out as anything other than 0 and it leaves me with a remainder, in that case it's not on the x-axis and it would not be a solution. So it says use the remainder theorem and synthetic division, so we'll use synthetic division to check. So we're looking at negative 3. We have 1, 10, negative 24, 20, and 44. Let's make sure we're all on the screen. So bring down the 1, I get negative 3, gives me 7. Negative 21, I got negative 45. 3 times 45 is 135, which looks like I get 155. And negative 3 times 155. I get 465. So with the remainder there, I would say that f of negative 3 equals 465, and that is certainly not a solution of the function. So now we lose negative 2 in the same way. Bring down the 1. I get negative 2, gives me 8. It's negative 16, which gives me negative 40. I got 80 there, which gives me 100. Negative 200, looks like 200 minus 44 is negative 156. Leaves me a remainder, so I'd say f of negative 2 equals negative 156. Oh, made a slight error up here. This is 155, so we said 155 times 3 is 465, so that's negative 465. Minus 44 is 421. So this should be negative 421. I think I caught that. In number 59, we have to first verify that the given factor is a factor of the function that we have. So we're looking at x minus 4. So I'm going to use synthetic division. Put the 4 here, and let's solve through. I get 1. 4 and 4 is 8. Gives me 32, which comes out to be 7. And 28, 0. So I'm left here with x squared plus 8x plus 7. So it does work. It is a factor. Next part, find the remaining factors. Now I have x squared plus 8x plus 7. Factors of 7 that add to 8, that's going to be x plus 7, x plus 1. So my other two factors, x plus 7, x plus 1. Use that to write the complete factorization, which is here, bringing down the x minus 4. And then D, list the zeros. The zeros are going to be positive 4, negative 7, negative 1. Look at number 63. We need to use the rational zero test to list all possible rational zeros. So we're going to take the factors of negative 3 and the factors of 4 and write all the possible fractions we could have there. So 3 I got plus or minus 1, plus or minus 3. For negative 4, or positive 4, I have plus or minus 1, plus or minus 2, plus or minus 4. So now I need to match up each one of the numerator values with each one of the denominators. So I'll start with matching the 1 with each numerator. So I got plus or minus 1 over 1, plus or minus 3 over 1. Next I'm going to do plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, plus or minus 3/4. And there's my list of all possible zeros. We use the cart rule of signs to find the possible number of positive and negative solutions. So if I just think of a positive value of x, I get a positive, negative, positive for my signs. And that gives me two changes in signs, so the possible positive solutions are 2 or an even number less than that, which would be 0. If I think of g, or the x value in the function being negative, this becomes a negative, a positive, a positive. I have one change in sign, so I have one negative solution. For number 67, we need to use synthetic division to verify we have an upper and lower bounds for our real zeros. So we start with an upper bound of being 1. So I'm going to put 1 in my synthetic division. and I get let's see, we got 4, oh, that should be 1, 5, 5, 2. Now, all of these values turn out to be positive, and so that means that x equals 1 is an upper bound. For the lower bound, I'm going to do negative 1/4. And these come out to be alternating signs, so that means that x equals negative 1/4 is a lower bound. Number 69, find the real zeros of the function. So let's start with our possible zeros. And those are going to be our factors of 10 over the factors of 6. So we got 1, 2, 5, and 10. 1, 2, 3, and 6. So this actually gives us a long list. Our possibles, if we worked this out, come out to be 1, 2, 5, 10, 1/2, 5/2, 1/3, 2/3, 5/3, 10/3, 1/6, and 5/6, and all of those are the plus or minus. Now we're going to use synthetic division to solve. I'm just going to make it easier on ourselves, and I'm going to suggest we try 5/6. We could guess and check, but you're here to get the homework answers. Why do I need to guess and check as I go through all of them? So 6 times 5/6 is 5. Got to get 36 here. 5/6 of 36 is 30. Comes out to be 12. 5/6 of 12 is 10. Leaves me with 0. I now have 6x squared plus 36x plus 12. I can factor out a 6 from that. X squared plus 6x plus 2. And this is not going to factor nicely, so I got to use quadratic formula. So that's going to be x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 2 over 2. This comes out to be, looks like a 36 minus 8, so a 28 over 2. Now 28 I can make into a be 4 times 7, so it's 2 root 7 over 2, and this becomes negative 3 plus or minus root 7. So our zeros turn out to be x equals 5/6, the first one, then negative 3 plus or minus root 7 is our other 2. That was nice. Okay, 71. All right, so we are looking at our possibles being the factors of 18 over the factors of 6. And when we write all of these out, we get 1, 2, 3, 6, 9, 18, 1/2, 3/2, 9/2, 1/3, 2/3, and 1/6. All of those are the plus or minus of those. So we got a lot of options there. We could use the guess and check. Let's just make it easier on ourselves and use negative 1. Why am I using negative 1? Because I know it works. Okay, so 6, we got negative 6. It's negative 31. 31 gives us 45. Becomes a negative 45. We got negative 18, which becomes positive 18, and I'm left with 0. Now, I know negative 1 works. I'm going to look for another one because this is still in degree 3. It's still an x cubed. So why don't we try, I don't know, 3. 6 and 3 gives us 18. We got 13 left. 13 times 3 is negative 39, which gives us 6. 6 and 3 is 18. We got 0 left, so now we're left with 6x squared minus 13x plus 6, and we know 3 works. Now, we could check quadratic on this one, or we could look at factoring. So I'm looking at what can I get, multiply 36 that adds to negative 13. And it looks like I could do like negative 9 and negative 4. So I'm going to factor those. So let's turn this into 6x squared minus, I'm going to break 13x into a 9x and a 4x. Because this lets me now factor by grouping. I take the first two terms and I'm going to factor out a 3x. Leaves me with 2x minus 3. I factor out a negative 2 on the second one. Leaves me with 2x minus 3. Now I'm going to factor the 2x minus 3 out of those terms. Leaves me with 3x minus 2. So my solution here, 2x minus 3 equals 0, is 2x equals 3, or x equals 3 over 2. And over here, 3x minus 2 equals 0 is 3x equals 2, x equals 2 thirds. So I got those. So my solutions turned out to be negative 1, positive 3, 3 over 2, and 2 thirds.